Like everyone, I've got tons of devices that use USB power for charging. Cell phones, tablets, watches, Kindles, game console controllers, Bluetooth speakers, and portable power packs, just to name a few. I already have a couple of multi-port chargers, but I wanted a cheap one to keep handy for overflow. Enter the Orico? Either way, 20-watt, 4-port USB charger. This was the first thing I've ever ordered from AliExpress that arrived in less than a week and was shipped to the US. That was a huge surprise considering it was $9 at the time, including shipping. It will provide 20 watts total across all ports, and each port has a fast charging capability of 2.4 amps, which is 12 watts apiece. Note that it therefore obviously won't give full charge current on more than one port at a time, but it can get close on 2 ports. It supports intelligent charging on all ports, which will provide current according to what a compatible device requests. For non-intelligent or broken devices, it promises overcurrent protections so that you don't have a device or cable meltdown. And according to the manual, it is fireproof up to 750 degrees centigrade, which I kind of doubt, but I also can't test. You can see that it came with a North American power cable, but they should ship a cable with the appropriate connectors. There's not too much to say about the form factor that can't be seen on screen, but it does have a quality feel, a solid case, and decent weight. There's not much instructions other than a couple of odd safety notes. You shouldn't use it in a house with humid air, so basically they're saying that Florida can F off entirely. I get that condensing humidity is almost always a no-no, but they're saying that humidity in general is a problem. It's a bit of an overreaction in my opinion. They also declare that connecting to improperly grounded outlets are heated, which is very odd considering it has no grounding connector. The power connector on the USB supply only has 2 pins. Sorry everyone, that's a little out of focus, but at any rate the warranty isn't too bad at 18 months. But it does go on to say, for all items purchased in the Oracle Direct Store. I'm not sure if that refers to just the tech support or the warranty as well, but it could be a bummer depending on where you get it. The upside is that the seller of the item on AliExpress is called Oracle Direct Store. So make sure you buy it from them if you're interested in the warranty and or tech support. To get my testing started, I have the Oracle Direct plugged into my phone for a lot easier to measure overall power consumption. I've got 4 cell phones plugged in and charging, and Nokia and both plugged into USB power lines. As you can see, with all the screens powered up, it's about 24 watts. Now it says it's a 20-watt charger, so what's up with the extra watts? Well, Oracle promises an efficiency of 85%, meaning that 15% of power was lost to the voltage reduction and rectification, and 85% of 24 watts happens to be 4 watts, which is better than spec. Though I'm not measuring the current draw each port, it looks to me like the Oracle is trying to save the amount of energy. I didn't measure the temperature properly, but having left these phones connected for about 15 minutes, that resulted in the Oracle getting slightly warmer than far. Next, I connected the Oracle to my oscilloscope, which showed a very solid DC voltage, which did fluctuate gradually from 5.2 to 5.36 volts. Plugging in a load caused a spike, which maxed out at 7.92 volts. Once under load, the voltage increased to 5.52 volts. The USB spec says that voltage should be between 4.75 and 5.6 volts. I have no problem with this PSU running so close to the max because there will be some voltage drop in the device due to resistance in a USB cable. The slightly higher voltage will then allow for slightly higher charge wattage when the current is capped at 2.4 amps compared to USB power supply that operates at exactly 5 volts. So far I'm pretty happy with this charger, but what about electrical safety? The construction of the case is the first important consideration, and as you'll see later, this is very hard to open. Some cheap power supplies have cases that can easily fall apart or crack when dropped or otherwise abused, potentially leaving live electrical contacts exposed at full line voltage. Another thing to test out with USB power supplies is current leakage. I have to give a big thanks and a shout out to Clive at his excellent YouTube channel bigclive.com for bringing this to my attention with a couple of his recent videos. Because USB chargers derive their power from line voltage, or the mains, Clive calls, they can unintentionally or as part of their design leave current to ground, the body from the perspective of electrical safety. The positive DC output is live at about 34 volts AC to ground, with a maximum short circuit current of about 20 microamps. The negative and ground from the USB supply also showed about 44 volts and the same current with 12 ground. This sounds really bad, but 44 volts isn't that high and the current is extremely low. Currently, ground is a common switch-mode power supply, so we'll find out if that's what's inside this in a moment. this episode of Let's Quickly Open. I had been hoping that the bottom cover was simply latched into the case, but after a couple of minutes of prying it became clear that it was probably glued or welded. I broke out the heat gun because I figured that neither case that would help loosen it up, and it beats the mess made with the Dremel. After a couple of minutes, I managed to get a decent purchase and leverage using a 5-in-1 tool and popped off the Dremel with a bit of force. It looks like it was welded at about 18 spots all the way around. The circuit board wasn't welded as fast, but it was captured by a small piece of plastic under the power pack. It finally came free, and my first impression was that it was well designed and solid overall. You can see right away that it was a very hard anti-traction slot. Power is further conditioned by two unmarked inductors, which appear to be wired in series. Then it's rectified to DC by a full bridge rectifier on the underside of the board, and the power is then smoothed by a bank of 400 volt 10 microfarad electrolytic capacitors wired in parallel. After that, it gets a bit hard to figure out because this is a dual-sided board with tracks that are well covered with black ink. Suffice to say that it does appear to contain a fairly robust switch mode power supply. I hadn't noticed when disassembling it, but there really is incredibly good isolation between the high and low voltage components due to a section of the case which actually protrudes through the board. Where that slot is not present, there is fairly good distance between the components on the order of about 6 millimeters. All of the components are placed very square and true to the board, with the exception of the 817C upto coupler, which is at the end of the board and strangely at a severe angle, and its leads don't protrude all the way through their holes. On the upside, the heatsinks are tied independently to the board. Based upon my initial testing and what is granted a fairly cursory look at the electronic components, this little USB power supply seems to be a great value at $10 US, and fortunately it still appears to be working despite a bit of abuse. But I'm not what you'd call an electronics expert, so if you have other observations about this unit, please leave them in the comments below. And if you're interested in a closer look, I've put a few high-quality macro images of the PCB on my site at s.co.tt. Thanks for watching this episode of Let's Quickly Open. I'm hoping to get some more review and teardown videos out shortly, so please subscribe if you're interested. You can also find me on Facebook, Google+, and Twitter, all of which are linked to from my blog at s.co.tt.